Trigonometric functions. So before we go into our functions, let's go over a triangle, and specifically a right angle triangle. So here we have a right angle triangle. Now we know it's a right angle because we'll just show right here to represent 90 degrees. So let's go ahead and label this. So right here we have our acute angle. Then this side right here on the bottom is called our adjacent side because it's right next to our acute angle. Now, the one that's going vertical is called our opposite side. And then we continue to have our hypotenuse. So with this in mind, let's go now over our functions. So we have 6 different functions. So when we show a sine angle, we have sine of the acute angle, and this is going to be the opposite over hypotenuse. Now our cosine angle, which is also represented like this, is our adjacent over hypotenuse. And then our tangent is just our opposite over our adjacent. So that's how you represent them. So we have a sine of some angle, which is equal to opposite over hypotenuse, for like that one. Now we have cosecant. Cosecant, which is written as CSC with an angle, is the hypotenuse over the opposite. So you can see that it's like sine, but it's just flipped. Now our secant, represented like this, is our hypotenuse over our adjacent. And then our cotangent is our adjacent over our opposite side. So you can see that all these are really just ratios. Given an acute angle, there is a certain ratio of the sides. Meaning, if we have a certain degree of an angle, these sides all must be a certain number in order to be equal. This is helpful when we need to find either angles or if we need to find certain sides of an acute angle triangle. So now let's go over some examples now. Example 1. We're going to find the sine of 40 degrees. Now the sine of 40 degrees is really asking us what the ratio is of the opposite over the hypotenuse. So let's get our calculators out. So we can go ahead and put 40, and then we see our sine button. So we're just going to go ahead and click that, and we notice that we get 0.64. So sine of 40 is equal to 0.64. So it's saying that the ratio between the opposite side and the hypotenuse is going to be equal to 0.64. Now let's do another example. Example 2. Find the sine of 75. So we're going to go ahead and place 75, and then we will put sine, and we get 0.97. So the sine of 75 is equal to 0.97. Let's do another example. Example 3. Find the cosine of 40 degrees. So this time we're going to put in 40 and see what the cosine is of that. So the ratio for that one is 0.77. So the cosine of 40 is 0.77. Let's do another example. Example 4. Find the cosine of 75 degrees. So cosine of 75. So we'll put in 75, take the cosine of it, and we get 0.26.